Hello students, welcome back to our YouTube channel. So today we are still on secret problems now with the application of potentiometer. Yeah, these are some questions that the civic candidate don't like to even see in their question paper, whereas it's very easy. So here we are having a potentiometer, we are having a driver cell or a standard cell, we are having a test cell or an unknown cell. What is the main use of the potentiometer? The potentiometer is an electrical component which is used to measure the EMF of a unknown cell. It's okay. So you use a driver cell or a standard cell to measure the EMF of an unknown cell. So we are having a pointer here which is there to adjust the length of the branch XY. In such a way that the galvanometer will become equilibrium so that there will be no deflection in the galvanometer, therefore give us the reading of what? Of E2. So when at balance point means no deflection in the galvanometer, therefore we can now rate E2. So that's it. So we'll do a small recall here so that it should not be lost. Small recall. The key concept, the key principle or the key concept of a potentiometer. So the key principle of the potentiometer here is that at balance point, no current flows in the galvanometer. That is it. Also, the EMF is proportional to the length. So the EMF here is proportional to the length. This implies EMF is simply equal to a constant times L, where L is the length. So from there, you can simply say that E1, this E1, divided by the length across E1 is what? Is the length XY, is simply equal to E2, divided by the length across E2 is what? X cube. L, X cube. So the small n here is that E1 is simply equal to Vx x1. It's the same thing. So this E1 here, look at the ED here is the same as the ED across x1. So it's the same thing. So these are the key principles under the potentiometer. Balance point, no current flows in the galvanometer. Therefore, we have E equals to a certain Km. Therefore, E1 all over Lxy should be equal to E2 all over Lx cube. This is a formula to obtain. If you know this formula, no portion of the galvanometer will be and potentiometer will be more than it. Now, let us move to the next key principle. So the next key principle here is a condition for balance length to be obtained. Condition for balance length to be obtained. Now there are three conditions. Without those conditions, the balance length cannot be obtained. Means that we cannot have a balance point. The first condition here is that the wire, this wire that we are using XY, should be uniform. The cross-sectional area of the wire should be uniform. So I'll write here, wire must be uniform all through. Yes. The next one is the current in the wire must be constant. The current in the wire must be constant. The current in the wire must be constant. So this means that what the cell, for us to have a current which is constant, the cell here, the polarity should be the same. So positive should be going to be positive, negative should be going to be negative. For us to have a constant current. And the last condition, the most important one, is that the EMF of the driver cell, the EMF of the driver cell, the EMF of the driver cell should always be greater than the EMF, always be greater than the EMF of the test cell. Very important. Without it, we cannot find a balance point in between X and Y. That's it. If you're having an EMF, the test cell is having an EMF greater than the driver cell, therefore the balance point will be out of the lane. Therefore, it is not possible. So those are the three conditions, and the most important one being the dead condition. For us to have a balanced lane. Okay. So that is all about the record. So let us proceed now with a small example. Okay, students. So let us work example 1. Work example 1. In order to apply what we are just from saying. Okay, so that is a series for example 1. So example 1 is asking us determine the length for which the galvanometer shows zero deflection. We all know that one. When the galvanometer shows zero deflection, it means that we are always at balance point. And we all know that at balance point, the EMF is proportional to the length. This implies E across, look at E across XY, all over the distance XY. E across XY, all over the distance XY should be equal to E. Let us name this point Q. E across XQ, all over the distance L, where L is the distance. L is the distance from S to Q. Now, we are asking us to determine the length for which the galvanometer shows zero deflection. So, the data, this is the data that we are having. We are having the length xy equals to 100.0 centimeters. We are having the resistance of the wire xy being 2 ohms. Okay. Now, I'm looking for this small n. I should make L the subject. From this formula, that is correct. When you have your formula, you make L the subject. So L will be simply equals to cross multiply our Lxy times Exq all divided by Exy. That is it. From the formula, at balance point, we know that E is proportional to L. Therefore, if the EMF across XY divided by the length XY should be equal to the EMF across XQ divided by the length XQ, which is L. Now, are you having LXY? Yes, 100 centimeters. Are you having EXQ? Yes, 1.5. Are you having EXY? No. We are not having EXY, so let us go and find EXY. Now, to find the xy, we will consider this portion of our circuit. From here, we consider what? The resistance of xy is 2 ohms. So, there is a resistance of the wire here, and we are having also our resistor here. It means that this 6 volts, since these two are in series, this one is in series with the wire, therefore, this PT is being shared between them. So, without wasting time, my EXY will be simply equals to apply potential divider. So those that don't know how to apply potential divider, you should go and watch our previous video. Applying potential divider, our EXY equals to the resistance of E, the resistance of XY divided by the resistance of XY plus the 2.4 ohms. Plus the 2.4 ohms. So I'll have EXY equals to the resistance here is it 2 plus 2.4. I forgot times the voltage which is being set 6 volts and 6 volts. So this is, so after numerical application we will have 2 plus 2.4. So 2 divided by the answer times 6. So our answer is 2.7 degree volts. So this is the EMF across X, Y, 2.7 degree volts. Okay, so after finding EXY, we now come and replace our formula. LXY is 100 centimeters times EXQ. EXQ is here 1.5 volts divided by EXY. We are just from calculating it. It was 2.7 degree, 2.7 degree volts. So let us apply the numerical application. Okay, while applying the numerical application, L is giving us 55 centimeters. That is the length that we should obtain for us to have a balance point. So there is the length for us to measure this 1.5 volt. For the potentiometer to measure 1.5 volt, the balance point should be at 55, approximately 55 centimeters. So that is all about potentiometers. So if you have a question or a challenging question on that, then feel free to send inside the comment section of the channel, and don't forget to like, subscribe, and share to the others. So don't keep the knowledge for you. So see you for another amazing video.